Question number 13. A rod is pivoted at one end. The rod is pivoted at one end. Okay, rod is pivoted at one end. Fine, fixed at one end. Initially, the angle theta to the rod to the horizontal is 0. Okay, so it's horizontal. The weight of the rod causes a moment m about the pivot. About the pivot. So because of this weight of the rod, there's a moment which has been creating over here. So it can easily fall down like this. The rod is then rotated in the vertical plane. So it is now rotated in the vertical plane. Okay, maybe I can rotate it like this here, so that I can keep it here. I can keep it over here. Okay. Then, so the angle theta increases from 0 to 180 degrees. Wow, that's what I have done. So from here to here, it is 0 to 180 degrees. Okay. The graph shows a variation. Which graph shows a variation of m with theta? So which one will show the variation of m with theta? Now, what happens when the weight is acting like this? Then the torque is acting like this, right? Which means, what is the torque here? Torque will be acting like this. It's a clockwise torque, right? It's a clockwise torque. Cancel this. It's a clockwise torque, so torque is going like this. But now, when you start lifting this upwards, then what can happen? So as you keep on lifting this and come over here, so since this is your pivot over here, now the torque acts like this, which means what? Now the torque, the direction of the torque has changed, right? It is like this. So as a result of it, now it is outward over here, which means the direction of the torque is not going to remain a constant. It is definitely going to change, okay? And it changes once when we cross this, once when we cross this particular thing. So therefore, this is incorrect, right? The torque value is incorrect over here. So 90, 180, everywhere the torque is seen to be a constant, which is not seen. So here the torque is like this, here the torque is like this. And if it is like this over here, the torque is like this over here, right? So definitely this is not constant. So A is incorrect. Then what about B? Now what is happening in B? B, see, the torque value keeps on changing, it keeps on reducing, and finally comes to 90 degrees. When it comes to 90 degrees, when it comes to 90 degrees, it becomes 0. Does the torque become 0 here? The torque actually becomes 0. And when it comes over here, what happens? Again the torque increases and it's in the same positive sign. So it's a torque in the positive side. See, if this torque is considered negative, this torque should be positive. So therefore, torques are positive or negative. So this is torque in both the directions, it's positive. So B is also incorrect. Next, C. So here the torque is seen to be proportional to something like a straight line. It follows both the qualities. What are the qualities? It is changing positive to negative. It's changing from positive to negative, and it is decreasing and then increasing. Both the qualities are satisfied. But the problem is that how is the torque given by? The torque is given by something like the force multiplied by distance over here. As a result of it, it should be a non-linear curve. But here it seems to be a linear curve. It should be a linear curve. So therefore, it is not a linear one. It is a non-linear one. And as a result of it, this is also incorrect. The last option left out is D, and this actually is the right option. Okay.